Alrighty, hello, those of you at home. Here is your warm up, right? Oh, no, that one's when we return from break. There it is, guys. So Penny keeps wishing for her dreams to come true. Which dreams? Whichever. You guys know how to read. Pause the video, read this, do the best you can, and let's see what happens. Alrighty, guys. So what we're going to do here is we're going to talk about this situation. So on Monday, Penny throws 3/4 into a well. Nathan, how much money has she thrown into the well on Monday? Uh huh. Oh, that would be Tuesday, I think. Yeah. But so $1.50 on Tuesday. On Tuesday. And then I think I asked for Wednesday as well. How much would it be on Wednesday, Nathan? $2.25. And then do I ask for Thursday? Let me see here. Let's see, for just Friday, and then Friday. How much on Friday, Nathan? $3.75. And then I think I asked for 12 total days. 12 total days. So how much money did she throw in the well at the end of 12 days, Henry? What was it? Oh, 36 quarters and $9. How many of us got that we're throwing it, that she's throwing in $9 by the end of the 12th day? Now, I have a question, Henry. Did you just count 3, 6, 9, 12, or did you do something else? 36. But how'd you get the 36? Mm-hmm. Beautiful. Did you guys catch that? He didn't have to count by threes the whole time because he knew that every day she threw in 3/4 per day. And if you multiply that by 12 days, the days divide out and you're left with 36 quarters. Now, the other thing that you can see, guys, is that if you multiply that by 0.25 cents per quarter, the quarters divide out just like a normal number, and it would be, oh, no, it's not 0.25 cents, is it? It's $0.25, right? Do you guys ever see that? I made that, oh, that's no good. Let's talk about that, though. I like that. And that would be $9. Can someone tell me, why was that wrong? You'll actually see this sometimes in, like, advertisements. But when I say teach, I want you guys to say, okay, why is that wrong? Give it a try and teach. Not last I checked. Okay. Can I get you guys in 5, 4, 3, 2, 1? Why? Why isn't that all right? Mira, why wouldn't that be okay? All right, someone say it at your table. Did you have it, Eddie? But go ahead. Maybe can someone tell me why this little thing 0.25 cents doesn't make any sense? Haha. Yeah, Skylar. Yeah, that's a quarter of a cent, and a quarter is just a quarter of a dollar. That's why it's called that. And what I kind of liked about what was happening here, I was about to make this mistake, but you could see that it was wrong because it would have told us that our answer was 9 cents. And we know that can't be right. If you threw in 36 quarters, you know the answer can't be 9 cents. So if you follow your units, that can actually help you check your answer, okay? Beautiful. Guys, it's the 59th day of school, so since 59 is the 17th prime number and 17 is prime, 59 is a super prime. Yes, indeed. It's National Pizza with the Works except Anchovies Day. So you go to a pizza place and you say, put everything on it except for anchovies. Has anyone here ever actually tried pizza with anchovies? I've always wanted to. I mean, I'll bet it sounds nasty, but I'll bet you it's actually better than you think it is. Please go ahead and stop that, guys. If you would, that would be wonderful. I would actually like you to focus on what we're up to up here. Okay, let's see here, guys. What is our first essential question? And I would love to get that from Miss River. Let's write that down. What does it mean to say a relationship? Oops. A relationship is or is not proportional. What does it mean to say a relationship is or is not proportional? While you guys are writing that down, guys, Bluey character breeds through the American Kennel Club. Chloe. This breed, dogdom's citizen of the world, is famed for its spotted coat and unique job description. That is indeed a Dalmatian. And then fruit, that's a pear. That's a pear. Alrighty, let's get to it, guys. Underneath all this, got a pencil? I could definitely use some more absolutely's out there, especially from that left side there. See if we can get that going. But anyway, in the meantime, let's go ahead and write down a title for today. Today's title is Proportional or Not. Okay, proportional or not. Okay, let's see here. So, a proportion, let's go ahead and say what it is. A proportion is a relationship in which one value is always the other multiplied by the same thing. Okay? A proportion is a relationship in which one value is always the other multiplied by the same thing. And one of the ways we can keep track of this is on a table. Like, for example, that warm up, we could call that day and dollars. And after 1 day, there was $0.75. After 2 days, there was $1.50. After 3 days, there was $2.25, I believe. Was that right? And then after 5 days for Friday, wasn't that Friday? Was $3.75. And then after 12 days was $9. That's kind of a way that you could keep track of that. So my question is this relationship proportional? That is this number just one of these numbers multiplied by the same thing over and over again? Is that true or is that false? I would say that that is true. Well, let's find out. When I say teach, I want you to say, okay, is there a number I can multiply all the days by to get all the dollars that match with them? Give it a try, and here we go. Teach! Okay. Can I get you guys in 5, 4, 3, 2, 1? Liam, what do you think? Is there a number that I could multiply all the days by to get all the dollars? Yeah. What number? 0.75. Beautiful. By the way, that was a really good countdown from 5, and I think you guys do deserve a point for it. Thanks so much, everybody. Oh, yeah. Okay, let's see here, guys. So, this is a proportion. We're going to write that down. This is a proportion. Dollars equals 0.75 times days. That is a proportion. We're going to add a little bit to this sentence here because that number has a special name. That number we multiply by is called the constant of proportionality. I know, really annoying to write, but you guys don't have to write it. We have to write it on the test. Nope. The number that we multiply is called the constant of proportionality. So when you say that you're multiplying the number of days by 0.75, you're saying that this is a proportion and that the constant of proportionality is 0.75. Does that make sense, guys? Okay, let's try another one. Let's see here. I'm going to scroll there. So, oops, wrong one. There we go. Once you get that written, let's make another table, guys. Let's see here. I'm going to do X and Y, and you're going to see why X and Y are so common. Like, have you guys ever wondered why X and Y are so common in math classes? How many of us have wondered that before? Maybe? Yeah. It's like mathematicians, right? Like, it's like that joke where it says, "Dear math, please stop asking about your X. She's gone, and we don't know why either." Anyway, I want you guys to go ahead, and I'm going to call in some people, and they're going to give me some numbers, and we're going to see if this thing makes a proportion or not. Let's see here. Oh, no, I already called on that person. Josh, give me a number. 1. If 1 goes in, 4.5 comes out. Give me another number, Josh. 8. 22. I would like another number, and that's going to come from Skylar. Give me a couple numbers. Make one of them negative. -8. -18. And one more, please. 19. Okay, 49.5. So when I say teach, I want you guys to talk to each other. Is this a proportion? Is this proportional? Is every single number that we got, so you guys gave me numbers, I did something to them and gave you the numbers back, can every single number be obtained by multiplying your x's by the exact same number? Can I take a number and multiply it by 1 and get 4.5 and then multiply by that same number and get 22? Give it a try. Well, talk about it. Talk about it. Give it a shot and teach. Let's go ahead and make sure we're getting that written too, okay? Get this one down. Oh, so sorry. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here. Skylar, what do you think? Is this proportional, yes or no? Why not? Well, I'm glad we're talking. I actually heard Mira describe it really well. And this time I'm sure I heard Mira describe it really well. Mira, what were you saying? So, and what would we have to multiply 1 by to get 4.5? So this would be 1 times 4.5. Very good. Awesome. There we go. I love it. Let's see. Let's make sure. Let's see. Let's see if that tracks here. Get this open and moving. Just give it a second. It's like the preloading part. Should probably be a song for this. TI SmartView TM emulator software for the TI-30X/TI-34 multi-view. TM calculators, Texas Instruments, validating software license. Dot. Oh no, dot. Hello? Are we working? Maybe, okay, maybe it didn't like the drum roll. Okay, so if you do 8 times 4.5, you do indeed get 36. So that is one way to check, is to see if you can find one that multiplies to make it. You have to check to see if the same thing. But I'll tell you right now, once it's broken for good. Once it's broken for good. I do not have to check the rest of these. After seeing that once, how many of us feel like this makes sense and they're doing okay out there? Beautiful. This is not proportional. Should we do another? Okay, here we go. A and B. I want a couple of numbers, and I don't want any of them to be 1 or -1 this time. Tice, give me a couple of numbers.
2.
So? That would be 2 and -7. Okay, give me another one, Tice.
Give me
That would be 7. Okay, I want 2 more. I want 2 more. Let's see here. Let's see here. That would be Beckham. Give me 2 numbers. None of them can be 1, please. 4. Indeed. So 4 would be -14, and -4 is +14. So is this proportional, yes or no? And if it is, well, and if it is, what is the constant of proportionality? Teach! Beautiful. Thank you, Table C. Appreciate it. Keep it up, please. Okay. Can I get you back up here in 5, 4, 3, 2, 1. Let's see here. That's going to be River. Is this a proportion, yes or no? Yes, it is proportional. Proportional. And what is the constant of proportionality? 3.5 is the constant of proportionality. Okay. All right, we're going to go to one of my favorite websites because you guys, oh no, hold on, we got some questions. Miss Schuyler. Oh, it should be -3.5. You're right. Thank you so much. -3.5. My apologies, because it does do that. Yes, I'm sorry. Can someone tell me, how did you get that number? How did you get that number? How do we get that -3.5 so easily? Let's see here. We're going to go for, that's going to be Addie. How can we get that number? Addie A. I'm glad we're talking then. I'm glad we're talking. Can someone help us out? How do we get that constant of proportionality? Let's go for Emmanuel. Yeah, if you divide this number by this number, you got the -3.5. And then you can check, is -2 times 3 -3.57? Is 4 times -3.5 -14? There's a lot of ways you could do it. We're going to make one more of these before we kind of shift gears on here. But you guys are getting a little bit too clever for me to be able to just call on you and pick up numbers, because your guys' numbers, you're making it too easy for us. So let's go ahead and we're going to go to one of my favorite websites in the whole wide world, random.org.
Dang it. Come on.
Here we go.
Random.org. Save us with a 1.
Let's see here. That's true, but this will be fun too, because any excuse I have for these guys. Okay, here we go. So I want numbers between -15 and 15, and we're just going to have it in one column, and I want 6 numbers. Here we go. Okay, there they are. What? They were all positive? Hang on. That was, okay, there we go. That's better. Okay, here we go. So, oh, I'm sure you do. Okay, here we go. So our x's are -4, 7, 6. Oh, we already have 7. -5 and -11. Okay, so let's see here. This is going to be... Negative 4 goes in, and negative 0.5 comes out. Seven goes in, and 0.875 comes out. 6 goes in, and 0.75 comes out. Negative 5 goes in, and negative 0.625 comes out. Negative 11 goes in, and negative 1.375 comes out. So, table E, please don't talk through the whole thing. Okay, when I say teach, I want you to say, okay, is this monstrosity proportional? Is there a number that I can multiply those x's by the same number to get all those y's? Give it a try and teach. Yeah, check it. That's what you do. You got to check it. Okay, can I get you guys back up here in 5, 4, 3, 2, 1? For that. I heard so many people being like, nope, nope, nope. But what I really liked was I heard some people going, nope, wait, 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 wait. Because what do you guys think? Is this proportional? Big thumbs up, yes. Big thumbs down, no. What do you guys think? This, well, let's see here. Let's see. What did you think? Jane, no. Annie, what do you think? Is this proportional, yes or no? It is proportional. This is proportional. Can you tell me what's the constant of proportionality? Exactly. Archie, eyes up here. The constant of proportionality is 0.125, which is also known as 1/8. I actually heard a lot of really good conversations where someone said, I don't know if it's proportional because we're not multiplying, we're dividing by 8, right? We're dividing by 8. But the truth is, guys, division and multiplication are technically the same process. Dividing by 8 is the same thing as multiplying by an eighth. So it is absolutely okay if you divide this part. But also, I actually really liked what Tao said also. Tao said, if you go from y to x, the constant of proportionality is 8. But you can still use that to check for proportionality. Even if I do want the constant to take us from x, which is our independent variable, to y, which is our dependent variable, okay? Here's what we're going to do. We're going to look at a bunch of these, and we're going to decide if these are proportional or not proportional, okay? Here we go. Are they proportional? Check it out. I've got 3 tables here, a green one, a black one, and a red one. Are they proportional? If they are proportional, what is their constant of proportionality? If they are not proportional, how do you know? Give it a try and teach. You don't have to write these down, but you do have to check them. That's why they're on my PowerPoint. Hey, Thomas. Well, you might want to skip it to start and then see what happens later. Okay, can I get you guys back up here in 5, 4, 3, 2, 1? Guys, I'm going to point to these one at a time. If it is proportional, I want you to give it a polite little golf clap. If it is not proportional, I want you to give it like a disturbed murmur, like murmur, murmur. Here, what is your polite golf clap sound like? Let's hear it. That's perfect. What does your disturbed murmur sound like? Okay, indeed. Okay, what do you guys think of the green one? Okay. How about the black one? How about the red one? Okay, perfect. So I agree. Let's see. Let's see. So there we go. The black one is not proportional, but the green one and the red one are. Rico, what is the constant of proportionality for the green one? 4. I'm multiplying my x's by 4 to get my y's. And then let's see here. That's going to come from Jane. What's my constant of proportionality for the red one? So Jane, if you're not sure, take the y and divide it by the x. What's 12 divided by negative 4? Guys, I want to hear Jane, please. And let's check. Negative 4 times negative 3 is 12. Negative 3 times negative 3 is positive 9. Negative 2 times negative 3 is positive 6. Negative 1 times negative 3 is positive 3. 0 times negative 3 is 0. So this is a proportion. Someone asked about the 0, 0, guys. If I give you a 0, what should the output be? It had better be 0, because if there's only multiplication going on, that can really mess it up. How about these 4? We got a white one, a gray one, a brown one, and a green one. A white one, a gray one, a brown one, a green one. Which are proportional, which aren't? If they are proportional, guys, wait to divvy that up until I'm done talking, please. Shh. Okay, people are still talking even when I'm trying to ask them to settle in before I say teach. Okay, that doesn't work for me or meet my expectations. Okay, let's try that again. Just a lot of that's coming from table E also. I'm really, I'm not a fan of how they just kind of add on, like, it's kind of like I count down, and then they just kind of add something on there just to be funny, and it's not funny. It doesn't meet my learning goals. It doesn't make my expectations, and it doesn't make me happy. So knock it off. When I say teach, I want you to say, okay, which of these are proportional? If they are proportional, what is the constant of proportionality? Give it a shot and teach. Appreciate seeing you guys work together on doing the right stuff. Okay, can I get you guys back up here in 5, 4, 3, 2, 1? Let's see. The white one. Okay. The gray one. The brown one. The green one. Ooh, it sounds like we're all pretty much in agreement about the white one, the gray one, and the brown one, but it sounds like there is a disagreement about the green one. So let's see which ones are proportional, which ones aren't. That one's a no. That one's a no. And that one's a no. Okay. Can I get you in 5, 4, 3, 2, 1? Shh. The green one was a bit of a trap. Can someone tell me why someone might have thought that the green one was proportional, even though it's not? What do you think, Luke? Why do you think someone might have thought it was proportional? That's right. It doesn't have the 0, 0. That's right. But there's another thing about this that I think makes people think this one's proportional. It's a little thing here. What are you thinking, Taos? Yeah, it's got a pattern. Like these other guys had patterns though, and I didn't trick you on those. Table E, we are trying to have a conversation here, and you guys are just talking through it. That does not. Okay, that's actually not necessary. I'm in charge of that, okay? All right. Please stop. Taos was trying to say something, and you guys were very rudely talking over him. Taos, please say that again. I didn't hear. It's got a pattern, yes. So the pattern, it's got a pattern. I would say all of these guys have got some pattern to them, right? Like, I'll bet someone could tell me, what do you guys think 5 would come out to be? Yeah, 48. Yep. So that follows a pattern. This one's 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. What do you guys think 5 would be?
I don't know.
What do you think?
25.
25. It follows a pattern, but it's not a proportion because I can't take this number and multiply by this. You know what I think the green one did? I think it's because the green one adds the same number every time to this. Negative 1, 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. But is addition what makes it a proportion? No, it is multiplication only and slash division. So what is the... What would the... That's a different thing. That's a lesson for a different day. Let's see here. That's going to be Addie D. What is the constant of proportionality for for the white one? Close. Negative 5. Because 5 times negative 5 is negative 25. 4 times negative 5 is negative 20. So on and so forth. All right, next set. We got a green one. Well, how about that? I guess we got two green. We've got a green and gray, black and orange, yellow, brown, black and green, and red. Which ones are proportions? And if they're proportional, what is their constant of proportionality? Teach, teach! And
On the other side, you said that like it was only black and white. I don't know how to explain
if it's got a 0, right? Is that maybe what you're trying to say?
I don't know. Never mind.
Well, here, do you need to see it again? Here, let me freeze this really quick. Andy, do you have a question about one of these?
Yeah, the top one, this one. Because you said that if only like one of them was right, then it is proportional.
Actually, I said the other way around. If one of them is not right, it's the whole thing's not proportional. Like, yeah, I know that 1 times 3 is 3, and 2 times 3 is 6. But since 3 times 3 is not 12, it's done. It has to work every time. That's a great question. It has to work every time. Okay. All righty. Can I get you guys back up here in 5, 4, 3, 2, 1? Perfect. Thanks for having a good countdown for me there, guys. I appreciate that. Let's make sure that that carries on. Okay. How do you guys feel about this light green one, this green and gray? Okay. Orange and black. Okay. Ooh, that one made a stir. Yellow. Okay. Brown. Black and green. Okay, and red. Great. So it looks like there's a little bit of contention. Here are the ones that are not proportional. Yellow. And that's it. It's yellow. Oh, no, yellow and black and orange. Yellow and black and orange. Yellow and black and orange. So, can I get you in 5, 4, 3, 2, 1? I know it can be exciting when you think you found it. Like if you do 11.25 divided by 9, you get 1.25. 12 divided by 10, you get 12.5 divided by 10, 1.25. It looks like it works. 13.75 divided by 11, 1.25. 15 divided by 12, 1.25. 16.75 divided by 13 is not 1.25. And that was actually the point, is that if a single pair of values don't follow the rule, then the whole thing's not a proportion, okay? That's all I have for you guys. There's no self-assessment. Go home and let that cook overnight. We will talk more tomorrow and have a self-assessment to go with that. That's what I got for you guys. Thanks very much. Appreciate ya. Hang out in your assigned seats, and I'll dismiss you with the bell. And those of you at home, we will